Okay, now whatever you have seen just now, they are displacement time graph. We are now going to look at velocity time graph. How to distinguish between displacement time graph and velocity time graph. Velocity time graph, the label here is velocity, and the label on the x-axis is time. Okay, y-axis is velocity. Okay, so you know already. Then the first thing that I want you to know is the velocity is shown on the y-axis. What is the velocity now is shown on the y-axis. Earlier on, the velocity you have to calculate, it is not shown. You have to calculate from the slope. That's why every point I have to draw the slope for you to see, right? So you cannot see directly the velocity. But here you see the velocity, but you don't see the position. You don't see the displacement, right? It doesn't matter. We are going to know what to do, right? Then first thing is this shows the velocity lah. This axis here shows the velocity. Then the second one is the horizontal x-axis shows the time. Okay, right. So the two important thing that you need to know is number one, the slope of the graph here no longer represent the speed. The slope of this graph now represent the acceleration, or if it's a negative, then it's deceleration. Or if it's constant, then it's zero. But never mind. So the slope of the graph now shows the acceleration. Then the second thing is the area under the graph is the displacement now. Is the distance traveled or the displacement. So the two things that you need to know is this one, number 3, the slope represents the acceleration. The area under the graph represents the distance. And you have to remember these two, right? You have to remember these two. Okay, so we are going to look at the first graph here on the left. The graph on the left shows a straight line. Straight line now means as the time increases, the velocity also increases, because this shows the velocity. So as you increase the time, then you see, oh, velocity become bigger. You increase the time, the velocity become bigger. You increase the time, the velocity become bigger. So with a straight line like this, the velocity keep on increasing. What does that mean? The velocity increasing like that. So I try to find the slope of this blue line. I try to find the slope by using the coordinate. This point is 97, right? This point here is 0, 0. So I use 7 minus 0 divided by 9 minus 0. So 7 minus 0 divided by 9 minus 0 is the slope of this blue line. And the slope is positive 7 over 9. Now, what is the unit for the slope? The unit on the y-axis is meter per second. Then you divide by this unit here, second. So it is meter per second square. Right? So now I know this type of line shows a positive acceleration. It shows a positive acceleration. Next. Oh, didn't show this one yet. Yeah. Now, because I know the velocity, initial velocity and the final velocity, I can actually calculate how much is the distance traveled. The distance traveled is given by the area of this triangle. This is the area under the graph, the straight line. Under this blue line, this shaded area is actually how much is the distance achieved by the object. if the object move in this manner from 0, 0 to 97, from 0, 0 to 97, the displacement or the distance covered will be the area under the graph here. So I try to find this area. Since this is in the shape of a triangle, so I try to find the area of the triangle using half base times height. Half, the base here is 9, the height is 7, here is 7. This is 9, this is 7. So when I multiply them together, the area is 31.5. So I know the distance covered during this time is 31.5 meters. Okay, any question? No question. I'm going to repeat. I'm going to summarize what I've said earlier. Okay, right. Now, this is a velocity time graph. Velocity time graph, the characteristic is different from displacement time graph. First thing is the slope. The slope no longer shows the velocity. The slope now shows the acceleration. Okay. The second thing is the area. The area under the graph shows the displacement covered by the object or the distance traveled by the object. Okay, so there are two things here. And you need to find these two things, right? So I try to find them. I try to find the slope, and the slope is a positive number. Positive number means positive acceleration, right? Then the second thing, I try to find the area. Okay, the area here is 31.5, and 31.5 is the distance covered during this period of time. Okay or not? Right. So we go on to the second type of graph here. This second type of graph here, right? The center one. The center one is a horizontal straight line. And I have identified 2 points on the graph. Okay, the first point is this one, 0, 8. 0, 8, this point here, right? This point, 0, 8. It means that when the time is 0, the position is at 8. Not position, the velocity, meter per second. Meter per second. Why like that? The velocity. The velocity is meter per second. Okay, this is velocity. Sometimes the typing, I just copy and paste, then I didn't change the unit, right? Okay, so from this, I see another point here. This point is 10, 8. So this point is 10, 8. Okay, now using these 2 points, I try to find the slope. I try to find the area. Okay, you have an idea what to do or not? Using the 2 points marked on the graph, I try to find the area. I try to find the slope. Okay, right. So I try to find the slope. The slope is 8 minus 8 over 10 minus 0. 10 minus 0. Right? So the slope is actually 0. 0, but slope means acceleration. 0 means no acceleration. Now, no acceleration doesn't mean that the object is not moving. It can also mean that the object is moving with constant velocity. So in this case, the constant velocity is 8 meters per second. In this case, the constant velocity is 8 meters per second. Okay, now? Okay, so you don't have to be afraid. You see the question, find slope, find area, find slope, find area. That's all. Okay, now? Try to find the slope and find the area. Okay, right. Now, can you find the area? Can you find the area? This area here? The blue color? What is the shape of this? What is the shape of this
Square, a rectangle.
rectangle? How to find the area of rectangle? What times what?
A square times B square.
Ah.
Right.
Ah.
It's been a while.
What times what? Rectangle is the length times the breadth, or the width times the height, or whatever you call it. So how much is the
length times width?
Okay, length. How much is the length here?
10.
10. How much is the width here?
8.
8. So what is the area here?
80.
80. So it means that the distance covered during this period of time from 0 to 10 is 80, right? Is 80. Okay, so the displacement is 80, right? But for this case, because it's a flat line, it doesn't mean that the velocity is 0. It means that the velocity is constant. And that constant velocity is 8 meters per second. Right? Oh, this one is another one. Okay. You have any question to ask regarding these two cases here?
No, I understand.
Understand. So now you look at the graph on the right hand side. What are you supposed to do? If you look at the graph here, what is the two things that you need to do? What are the two things that you need to do here now? If you want to analyze the motion, two things.
Need to find the slope.
Correct. Then another one?
Then find the area.
Yes, correct. Okay. Now, in order to find the slope and the area, you have to identify 2 points on the curve, on the straight line. One is this, another one is this one, or any point along the line here. Okay. So what is the coordinate of this point here? The coordinate of this point?
6, 8, 9, 8, 7, 7, 7.
0, 0, 7. It means that when the
Yep.
time is 0, the velocity is 7. Okay. What is the coordinate of this point? The bottom one. Sorry.
Wait.
This point here. What is the coordinate?
0, 12. 12, 0.
Correct. It's 12, 0. It's 12, 0. So by using the coordinate of these 2 points, you can actually find the slope. Okay, you can actually find the slope. So you use 0 minus 7. Again, yeah. This one is velocity. This is velocity. It's no longer displacement time graph, it's velocity. If it's velocity, then the unit is meter per second. If it is velocity, then the unit is meter per second. Okay, right. So I want to find the slope. So I use 0 minus 7, 0 minus 7, then 12 minus 0. So the slope is 0 minus 7, 12 minus 0. But the answer is negative 7 over 12 meter per second squared. Why is it negative? Why is it negative? Now, can you see that at first the velocity is 7, then finally here the velocity is 0. What is happening to the velocity? At first is 0, at first is 7, finally is 0. The velocity is increasing or decreasing?
Decreasing.
Decreasing, correct. So that's why we have this acceleration is negative, right? So you need not worry about whether it is positive or whether it's accelerating or decelerating. You just look at the sign here. Because the acceleration is a negative number, it means that the velocity is decreasing. Now, when the velocity is decreasing, right, the acceleration is negative lah, negative or deceleration. Now, although the velocity is decreasing, but there is still distance covered. You see, it's still moving, so there will still be distance covered. Can you tell me how much is the distance covered during this deceleration period? How much is the distance covered during this deceleration period? The two things you need to find, remember?
The area, wait, I'm trying to figure out what's
Correct
the area for
area.
triangle.
How much is it? Area is half base times height. Half, what
Yeah,
is the
I'm seeing it.
base?
Half
Base
base is
is
12,
12. What's the height?
7.
Correct. So how much is the distance?
$42.
Correct, 42. So the distance covered during this deceleration is 42 meter, right? The unit must be meter because here meter, the unit here is meter. Then the velocity is decreasing, and it will decrease until from 7 and until the velocity is 0. So with knowledge of this velocity time graph, with knowledge of the gradient and the area representing the displacement, so you can read this, you can read this, you can read this. You see,